Hi guys, welcome everyone. Welcome back to um, second semester. So we're gonna hit the ground running. The difference this semester, since we got through lesson 80 and now we just have to get through 120, we have 40 lessons to go. We're not gonna have to go as fast. The reason is some of these get more complex and I'd rather have more time to do them. So with that being said, we're going to do the recordings per week, so not every single day. So you can break it up however you want. Hopefully, the goal and the expectation is that you have them watched before you come to class. So whatever lesson we're doing that day. So I would just watch them all before the week starts, just so you have it done. But if you want, we're doing lesson 81 on Tuesday and 82 on Thursday, and you want to pause and come back to it, that's okay too. But we're probably going to be doing 2 to 3 lessons a week as opposed to 3 to 4 lessons a week, just because we have a little bit more time to slow down and really dive deep. All right, so today and this week, we're looking at lesson 81 and 82. So lesson 81, let me make sure I'm all... Okay. Lesson 81, we're using proportions to solve percent problems. Okay. So our new concept, and not really a new concept. We've used these ratio boxes and filled them out. It's just if we are using percents, okay, instead of ratio and actual count, we're going to use percent and our actual count. So percent is a ratio. It's always per 100, so out of 100. So 30% of the lunchtime customers ordered salad. Okay? If 21 customers did not order salad, how many lunchtime customers were there? 30, 70, and 100. So we fill in what we know. We don't know how many ordered salad. We know 21 did not order salad, and we want to know the whole group. Okay, so 70 out of 100. It's always out of 100. So even though we were only given 30%, well, 30% did. That means 70% did not, because it's got to always add up to 100. The whole group always adds up to 100. So that's how we're able to fill in this side. The actual count, we were given 21, and so we set it up 70 over 100, because we want to know the whole group. You can use W, X, Y, whatever you want. 70 over 100 equals 21 over W. Since the 70 and the 21 are in the same row, and then the 100 and the W are in the same row, that's why they line up here and have to line up. Cross multiply, we get 70W equals 2100. Then we divide by 70, and we get W equals 30. So there were 30 customers. Could go through and do the same thing to solve for how many ordered a salad, or even easier than that. If 21 didn't order a salad and there's 30 in total, you can just easily find the difference between those and figure out that 9 people did order a salad. So 40% of the students at Lincoln Middle School do not buy their lunch in the school cafeteria. 480 students buy their lunch in the cafeteria. How many students do not buy their lunch in the cafeteria? Okay. So percent, 40%, okay, do not buy their lunch. So that's where we get this number. That means 60. You either don't buy your lunch or you do buy your lunch. So again, there's only 2 options. Then we put our total, which we know is always out of 100. So that's how we fill in the percent side. Our actual count, we know 480 buy their lunch. Okay. So we set it up. We want to find the number, our actual count, and number of students that do not buy their lunch in the cafeteria. So we set it up. 40 over 60. We could reduce it down before we cross multiply and divide if we want. It's going to work out to be the same number, so that's up to you. So 40 times 480, 60 times n. 60n equals 19,200. We multiply those two. Then we divide by 60 both sides, and we get n equals 320. So once we have it set up, it's like we've been doing all year. We just cross multiply and divide. Cross multiply and divide. So that gives us 320 students. Again, we get a whole number, which makes sense for this example. So 320 students do not buy their lunch in the cafeteria. Okay, if we're looking at example 2, in the town of Centerville, 261 of the 300 working people do not carpool. Now we want to work backwards and find a percent. What percent of the people carpool? Okay. Well, you either carpool or you don't. Okay, 300 working people, so that's our total in our actual count. So that's our 100% of what we're working with. 261 do not carpool. And we can find the difference to figure out 300 minus 261 gives us 39. Do carpool. Okay, and we want to try and find what percent of the people carpool. So we're going to say X or Y or Z or PC, in this case, what they're calling 100 equals 39 over 300. Cross multiply, we get 300x or 300p, whatever, equals 3900. Cross multiply and divide both sides by 300. We get 13. So 13% of the people who work in Centerville carpool to work. B, according to one national survey, approximately 13% of the working people in the United States carpool to work. Do the carpooling statistics in Centerville reflect the national pooling statistics? Yes, since we got 13% that do carpool, it's exactly a reflection of the national statistics. It's not always going to work out to be that way, but in this example, it was a pretty accurate reflection. So it depends on, maybe it's a really, some towns may have no carpooling if it's really small and there's no need for it. Other, big cities where you travel a lot and there's a lot of traffic and it's easier to carpool, might have a higher statistic. But yeah, this was a decent reflection of that. All right, the students had spelling tests with 40 words. 6 of the words had 4 syllables. The rest had less than 4. What percent of the words had less than 4 syllables? So less than 4, 34. Actual count, 4 syllables. 6. Total percent, we know is always 100. Add those two together to get 40. We want to know what percent had less than 4. So we're going to do PL or P of L or X or whatever you want over 100 equals 34 over 40. Cross multiply and divide, and we get 85%. So you may be wondering, well, when will we use this? Well, let's say you got a test back and it says 36 out of 40. What's the first question I always get? What is my grade? What is this? Well, you can go through and do this. You can set it up. Okay, well, percent. So we know it's always out of 100%. We want to know what we got right. And that's preferably what we want to know. Okay, we know, set it up in a ratio, X over 100 equals 36 out of 40, cross multiply and divide. And we get 90. So X, or how many we got right, equals 90%. So now you don't even have to ask me, what is my grade? I got a 35 out of 40. I got a 29 out of 40, whatever it is. You can just set it up and do it. Now, I think even an easier way to do this, and to be honest, how I would probably do it, if you said, okay, I got a 36 out of 40. What is that? Is I would probably just, we would do it by hand, or since we're allowing you to use calculators, that's an option as well. I'd probably just go in and do 36 divided by 40 in my calculator, and that's going to give you 0.9. So we know that as a percent is 90%. Or you could then go and do times 100. We know 0.9, move the decimal 1, 2 to the right. That's 90%. So this is how I usually do it. You can set it up where you have the percents, hundreds, your ratio boxes, which we've been doing all along. Nothing wrong with that. Just sometimes I think it's easier. Well, we know how many we got out of the total. Just do the division, and then that's going to give you a decimal, but then you can quickly and easily convert that to a percentage. So that might be how I would go about doing it. But either way, we should arrive at the same answers. Practice set, we'll do those together. All right, and then the next day we're going to be looking at area of a circle. So nothing brand new about this. It's on your reference sheet. I know we've talked about it before. Okay, area of some of our shapes, length times width, base times height. Triangle is half of a parallelogram, so 1/2 base times height. If we're looking at a circle, we know we have a radius and a radius. If we were to create 4 congruent squares that enclosed our circle, it will diameter times diameter, that would be a little bit more because we would have these corners that would be left out. So it's going to be close, but it's not going to be 100% accurate. So we go through all of this and through much thought and experimentation and things very long ago, they came up with the accurate equation for area of a circle, and it's pi r squared. So if we know the radius, we just plug it in. Or if we are given the diameter, we can easily find the radius because it's just half of the diameter. So plug in r, so r to the power of 2 times pi. We usually use 3.14 or 22/7, or just leave it as pi. But that is our equation. So if we have 3, make it as close to a circle as possible. It kind of looks egg-shaped, but we'll use it. So our first one is 10 centimeters. Oof, what is 7 inches and 12